Good afternoon. This presentation summarizes an eight-part blog series assessing Saudi Arabia's power system transition under UN Sustainable Development Goal 7 affordable and clean energy. My name is Malik Al-Anizi, a mechanical engineering student focused on sustainable energy system. Over the next few minutes, I will walk through the problem, the current and future energy system, a technical comparison, the supporting data study, the ethical dimensions, a workplace awareness, activity, and my conclusions. Energy access remains a global fault line. Roughly 685 million people have no electricity and 2.1 billion still cook with polluting fuels. Saudi Arabia has solved universal access, but its own challenge sits separately on targets 7.2 and 7.3. Renewables contribute barely 1.2% of generation, and energy intensity runs 30% above the OECD average. Globally, renewable capacity must nearly triple by 2030 to stay on track. This blog series uses SDG 7, showing here with its 5 key targets as the lens for assessing the kingdom's power system. The system supports this assignment. The current system is the kingdom's hydrocarbon fleet, combined cycle gas turbines and oil-fired steam plants, which generated 388 terawatt hours in 2023, reliable but emission intensive. The chosen future alternative is utility-scale solar photovoltaics, selected because Saudi Arabia sits in the world's top radiance quarterly. Projects like their 1.5 gigawatt tracker plant already delivered some of the lowest solar droughts ever recorded worldwide, providing the technology is mature, not speculative. Comparing 1 gigawatt of each technology on a like-for-like basis, solar PV is roughly one-third the cost, 20 times cleaner, and 65 times less water intensive than gas. CCGT. Gas retains the advantage of dispatchability and land footprint, since PV needs more space and lacks storage on its own. The engineering verdict is not that gas is obsolete, but the PV should become the backbone with storage integrated refro, reinforcement, closing its remaining weaknesses. Because grid scale questions cannot be answered with a bunch experiment. That practical activity is the structured data collection exercise, defining variables, sourcing them from IEA, IRN, IPCC, EIA, KAB, SARC, and the Ministry of Energy, extracting 5 years of time series and delivering inductors. The chart tracks the SDG 7.2 inductor directly renewables share of Saudi generation, which grew from 0.15% in 2019 to 1.21% in 2023. The headline delivered results substituting 1 gigawatt of PV for CCGT avoids about 104 megatons of CO2 equivalent over a 30-year plant life. Engineering choices distribute benefits and burdens so that project support its ethics. In the Mechanical Engineering and Engineering Council framework, four themes stand out: equity of access, since cleaner air and local jobs must be balanced against transition risk for hydrocarbon workers; intergenerational equity, given the kingdom's high per capita emissions; procedural ethics, applying Belmont report safeguards to the awarenesses activity and honest trade-offs, naming PV's land use, recycling and supply chain limitation rather than hiding them. The social awarenesses activity took the SDG 7 message directly to the 5 colleagues at Advanced Petrochemical Company in Jubail with a full written consent. The post-activity quiz average 6.6 out of 8, 82.5%, showing strong retention, though CO2 intensity and water demand were the weakest areas, suggesting cost is better understood than environmental externalities. Note that the source material documents only post-activity sources, no pro-activity baseline quiz was recorded. Discussion was on nominees that solar is economically rational with regard to stability at high penetration, the main open question. The project changed how I evaluate engineering choices, from seeing that shift to solar as mainly environmental to reconsidering it as economically and technology rational once dispatchability, emissions, water and land are weighed together. The data collection exercise instilled a habit of traceability. Every number here can be checked against its source. In delivering the awareness session in Jubail, confirmed that engineers have a duty not only to design better systems, but to explain why they are better. My commitment going forward is to keep advocating for that transition and keep communicating it. Thank you for your attention. I'm happy to take any questions on the technical, economic, or ethical dimensions of